Hi everybody, we are going to be taking a look at mass wasting and the movement of mass wasting. And as we look at that, we need to remember exactly how we have stuff to move, which is through weathering. And remember, by now you should know this, weathering is the breaking down of rocks and other materials on the Earth's surface. We've introduced this topic and this definition a lot. And there's three really main types of movement or of mass movement. And we have landslides and creep and slump. And that's what we're really going to be looking at now during today's notes. But to get that stuff, we remember we have to have erosion that has broken down the sediments to have the items that need to be moved or to be pushed. And remember, we can do that in multiple ways. We have erosion. Water can make rills and gullies, and we can move all that sediment down through a river, and they'll hit a delta. Waterfalls can erode back, and we have more rock that's broken down for us to be able to transport. And then we can transport it. We can have a mudslide, and it can be transported to a delta where the water slows down as it's coming from that suspended load in fast moving streams until it hits the slower moving ocean in this case, and it drops the suspended load. And we have braided rivers that is steep and erodible, and they transport things downstream. And then we've got, remember, organisms that burrow, and bacteria and fungi that decompose and break down that rock layer, and we get the soil horizons. And with all of that material that is broken down by all those processes we've talked about can move. We live on something called glacial till. A lot of our rocks are not native. I can't tell you exactly if you find a rock in your backyard where it came from, except I could tell you it could have come from Canada. Because as a glacier came through, it deposited and scraped all that soil and rock and plucked it. And it literally transported it from Canada all the way through northern Minnesota down here and farther down. Oh, why is that blinking so much? I'm going to pause for a second. Well, that would not be a good time for my computer to break down, but I think it was just getting a little hot, so I turned the fan on. So if you hear that in the background, that's what it is. My computer's trying to cool itself down. So we have all this ability for movement to happen because we have erosion, and we have weathering, mechanical and chemical, and animal, and the movement, and we move all of this material around. So as the glaciers came, all that loose soil got scoured along and dumped. And that's why we have these really odd features in Minnesota that don't really happen many other places in the world, and they're called lakes. Lakes are not normal. Gravity wants to fill them in. Mass wasting wants to erode the sides in. And, that's why in New Orleans we have to literally scrape out the sediment from the delta to keep that channel open. And sometimes you've got a pond or a lake that we dredge out. They did that at the pond across the street from my house years ago. They dredged it to make it deeper again because all this soil and sediment had washed in to try and level it out. So we live on transported soil, and we know that our soil got here from glacial movement, but there's other ways. So remember, this is important. Weathering breaks it down, erosion moves it, deposition drops it, and what are we talking about? Sediment. So it breaks down, it moves, and it deposits. And that's what we're really getting into. So the movement of rock and particles by wind and water and ice, all of those are forms of erosion. And remember, definition of erosion, the breaking down of Earth's surface. Deposition is to build up Earth's surface in a new location. Kind of like I had 6 dump trucks with 20 tons of crushed granite coming into my lakelet that we just had. We moved it. We actually moved it from one location where they broke it up by St. Cloud, and they moved it to my cabin so that I could have the start of a patio and a fresh rock layer on my driveway. So I deposited granite from one location in Minnesota to another. Now, the erosion that happened there was dynamites and crushing machines, so that's a little different. But we're going to talk about natural. This is a slump. You can see it's moved down. This is a river, and you can see where it is actually floodplains. This is all movement of sediment. These sediments didn't originate in this spot. They originated more than likely upstream. So is the material is the material moved by erosion, then its sediment has transported somewhere else. Deposition occurs where the agent of erosion lays down that sediment, where it drops it off. Might be in a delta, could be in a lake, could be at the ocean. It just depends on where it drops it. If it's by air, that could be like a sandstorm. It could be deposited in many different locations. Sand dunes move, actually, with wind and gravity. And gravity, remember, is that force that moves rocks from high up and drops them down, because everything is attracted towards the center of the earth. So gravity causes a lot of mass movement of sediment. Everything wants to go downhill. It wants to get to the lowest point it can get to. So weathering, erosion, deposition act together in a cycle that wears down the earth and builds it up in new locations. So weathering, erosion, deposition. This is something that we've talked about kind of continuously throughout this whole second semester, and obviously that's a good test question. Weathering leads to erosion, which eventually can be transported and deposited in a new location. The Grand Canyon was cut by more than likely water, and deposited that somewhere else. It cut down that canyon. Glaciers are fabulous movers and scrapers and of material from one place to another. They literally can pluck granite out. I mean, think of it. If you have 2 miles thick of ice and you're a rock on the bedrock and you've got a little niche and it gets stuck on it, you get more pressure behind it, it can literally start a crack, and it can pluck it up and move it down. And I'm talking boulders like the size of buses. If you go into Central Park in New York, they actually they're called erratics, and they're huge boulders left in the park from glaciers, and they were plucked from somewhere up north and moved downwards. So wind, also a great transporter of material. Our Great Plains have had a lot of soil loss due to winds and moving the sediments away. Waves are also good destroyers of sediment. They crash and wear away relentlessly day after day, and these cliffs will eventually move back. Rivers can do that too. Remember the cut bank in our rivers. So gravity, erosion, all of that is mass wasting. One of the big forms that I talked about at the beginning was a landslide. And landslide is rock that's up high and it literally slides down, and it can be massive. So when rock and soil slide quickly down a slope, what's it called? It's called a landslide. And here are some landslides. This is a very old picture of a landslide. It's a little harder to see, but these should be easier. This is a landslide. This soil gave way and it slid down the hill. Landslides can, that frost action, that repeated freeze thawing can literally loosen cracks in the side of a mountain, and you can have a boulder come down. If you've ever driven through the mountains, there are signs on the road that say beware of falling rocks, and they don't just mean little teeny tiny rocks, they mean big boulders. This is another bit of mass wasting, landslide, but it broke through the concrete barrier. That is actually a concrete barrier that is here that was designed to hold back the mountain should it fall. In fact, sometimes they put big nets up to try and catch it. Here is a landslide. It covered up the road and took out part of it. They're going to have to come and excavate that out and basically repave that whole area to keep traffic flowing through there. This is a mass movement, and if you notice, there was actually some fencing up there trying to hold that back, and it did not work. But look right here, you can see the fencing coming down around trying to hold that hill in, and that fence was there was no competition between it and gravity. Gravity wins. That is a massive landslide, one big chunk of rock side of a mountain coming down at one time. In fact, if you notice, the little guardrail up here even gets knocked down. And there goes the guardrail right now. Okay, this is a landslide, and you can see this is a cut bank because it's the outside curve. This is the point bar. It points to the cut bank, and this had enough waterlog that it loosened up the soil underneath, and we had a landslide. Here is another landslide, and you will see this part of the hill is about to go, and that train is not going to win against that mass movement. The only thing we can be thankful of at that point is the fact that there are no one in those train cars that got knocked over. And it's also amazing that they happen to be in the right place at the right time. But that's the thing with cell phones today. We catch so much more of this because people have phones on them and they take photos and videos. This is a collapse in Cornwall, and you see this cracking. Watch that whole side. It's about to fall into the ocean. And this is a landslide. All of those mechanical and chemical weatherings weakened it enough, and finally it just gave way. That's erosion in Cornwall. You want to see it one more time? Here we go. I like watching this one, as long as I'm not standing on it. It's also a reason why you should be very careful standing on the edge of the cliff, because you never know when that is going to give way underneath you. So, mud flows are another form, and guess what mud flow is comprised of? Well, it could have some rocks in it, and some soil, and it's going to flow down the hill rapidly, but it's really mud. I mean, it's water and soil that give way, and I don't mean to be flippant about it because it's a massive destructive force, and you do not want to be caught in a mud flow. In fact, a couple of years ago, I want to say, was it 3, 4, or maybe 5 years ago at this point, there was a massive mudslide in Washington State, and a lot of people lost their lives because they got trapped underneath it. So be respectful of mudslides because it can move whole parts of a mountain down. And if you watch, look, the trees haven't even fallen over. They're just sliding down the hill upright. They will eventually. Now there's some that were falling over because now it's starting to back up. But there it goes. That is a mudslide. That is water loosened soil. And again, if you looked over here right at the beginning, there was actually a fence trying to hold it back, and the fence isn't going to win. It might hold it back for a little while, but not forever. And you'll see there goes the fence right there. Okay, mudslides are dangerous. You do not want to be caught at the bottom of it. This is actually a retaining wall. Obviously, they've had mudslide issues in this area because they built the retaining wall to protect the road. And in this case, it was a small enough mudslide that it did. Now, they're going to need to either come and do this and move it back up there. A few years ago, and by a few years ago, I'm talking more than 10 at this point. If you are ever driving on 494 and going down that big hill after Highway 7 into Eden Prairie, and there was a landslide there. There was 3 of them. It was a really, really wet summer, and they came, the debris came all the way up to 494, and they had bobcats. You watched them. They were trying to push some of it back up the hill, but if you look, you can actually see these little circular depressions that are caved in where the land slid down. This is a mudslide that basically made that house uninhabitable. They're going to have to dig it out. This is interesting. This is a mud flow through the Swiss, and you're going to notice at the beginning of this, they actually have created flood channels because obviously in the mountains this isn't uncommon. Because look, they've actually made a rock channel for this to come through, and it works. I mean, it's definitely channeling it, but there's just a little too much mass, and it's actually going to come out past. But it will keep going to the extent it can, but they're going to have to get, heavy machinery in there to clear out that extra soil. There goes the sign. Okay, this looks like a nice northern sea, and you're leaving your fishing boat, but what you can't hear is there's probably thunder, because look, here comes a mudslide all the way down. In fact, they got out just in the nick of time because that actually is flowing out where they were just landed their boat. So, mudslides, if you hear a big thundering noise, move fast. This is more mudslides, covers up part of a house. The only way to dig that out is to get excavators in and dig it out. Same thing here. In fact, I think there is an excavator right there where they're starting to clear. The street here is clear, and they're starting to get this out of there. Okay, so landslides are big, massive movements of stuff coming down quickly, right? And then soil slump, and landslides I'm including in that mud flows because it's a big, massive, sudden amount of movement of earth. Soil slump is kind of like this. It literally slumps down. It's a movement, and you could actually see it happen. But what happens is the stuff down here, kind of like think of under a transform fault where everything is pulling apart, right? Not a transform, sorry. it's too late. I should be doing this in the morning. Divergent fault, where it pulls apart and you have a rift valley forming. You have less stuff underneath it, and soil can start to slump down into it. You can also have that on the sides of hills. So as it has less support, this part of the earth slumps down, and then it kind of moves farther and farther down. So then all of a sudden this part had less support and it moves down, and you just kind of keep slumping little bits each time, and it's very distinctive. If you see it, where you have a big drop right here, this is a soil slump. So this is not as fast a motion as a landslide, but it's definitely motion, and if it slumped and you were standing on it, you'd end up on your rear. This is a soil slump. This wouldn't be considered landslide because it's not massive amounts coming from up here, but it has slumped down. Now you'll notice this has wave action happening here, so this would be a Great Lake or a big Mille Lacs could have something like this, where the water could literally undercut the supporting foundations and the material and soil will slump down. And soil slumps are, it's a drop of a foot or so. It's not all the way down. It didn't fall into the ocean here, but it is slumping down. Here, soil slump, you can see slump, first one, second one, and if you kind of look, you're probably starting to see some cracks forming there. This next part doesn't have as much support. Eventually this will slump down too. And if it happens on the edge of a road, obviously it's easy to see, like this one is easy to see that this has slumped down there. The support down there gave way. This is soil slump. We saw this one, I showed you this a little while ago. It's also it's a cut bank because the water cut that side away and undermined all of that soil, and that slumped into the creek, or in this case river. I'm not sure which one that is. So again, can you identify what this is called? You should be able to tell me at this point that this is what? Soil slump. Okay, this is a little bigger than soil slump. So what would this be called? What is it? Can you tell me? So that's a landslide. And if you look at that landslide carefully enough, you'll notice there are houses back here. And there probably were some houses there. So that took out entire houses. So be respectful of gravity. You always want to know what's above you. This is a soil slump, except it's a sinkhole. That's another, we kind of define a sinkhole as a slump. But, if your house is built over a sinkhole, that can be a problem. Here is slumps. And there it goes. By the way, it took me years of watching this to realize if you watch this at the beginning, there's something hanging down. And that is a toilet hanging off a pipe that had already fallen out of the house. And that slumped. Enough of the soil underneath that gave way. By the way, there's a person right on this balcony watching this happen. And this is a soil slump. It just happened to be underneath the house, which is kind of a problem because it affected all the other houses too. All right, I've showed you this before. This is a slump. We have moving waters. It has a cutting action. The water eroded away its foundation underneath it, and that cliff, when it loses enough underneath it, gravity wins and it falls down. So it starts out there, and then we lose a little bit of its underfooting, and eventually we lose more, and more of the house ends up way down here. And we've talked about this before. Do not build your house on a cut bank or a floodplain, because water moves and it travels back and forth, and this house is being held up with a tree or a telephone pole or something like that. Well, a lot of telephone poles are trees, unless they're metal. Again, do not make it on a cut bank because it will slump into the water and undermine your whole foundation. I'm not going to show you this whole thing because we've looked at it before, but you should start to be able to see. Here's kind of like an alluvial fan deposits down here. You can kind of see that. And as we're looking at it, let me turn this off. You can see gullies and you can see some rills. And this is some slumping there, and there. This is a deposit of material. So that was probably somewhere between a landslide and a soil slump. And you can see rills here down the side. That's water cutting through. Here's almost a gully at that point. And this is slumping down. It's losing its support underneath. And this is going to fall down again and again. And that's why you've got all this debris down at the bottom. All right, the slow moving one. Now this one you're probably not going to notice it's happening, um, but you can see the effects of it. And soil creep is rock and soil moving or flowing very slowly down the hillside. And with that, we have soil creep. And trees will always try and grow up towards the sun, right? So you can actually, you'll be able to tell if there's creep happening on a hill because you will see it. And you'll notice that unlike the slump, this has little rivets on it, and we can tell it's slowly creeping downhill. Here it is too. But it's not that big chunks of drops and drops and drops back. It's little rivets all the way down. So this is a soil creep, different than a soil slump. But soil creep can happen slowly. So these fence posts were not planted at an angle. They were upright, just like these. But as the soil is creeping down, it actually moves the soil with it, and everything in the soil goes with it, including trees. Trees can creep down the hill. And when that happens, see how this is going straight out? Well, this had been growing upright, and it crept down, and it went down sideways, and trees want to grow up, so you get a curve. If you see this, you know the side of this hill is slowly creeping down. Here's more soil creep and trees that have bent to grow with the sun. These made it to the bottom. These made it all the way down the hill. And you can see where it went upright and where it curved, and now it's back to being flat. And look, it's almost like it just took a long detour to go straight up. But that's soil creep, and that's a full soil creep where it made it all the way to the bottom. Again, if I asked you this on the test, which I will, I would expect you to be able to tell me the difference between the big chunks coming down for soil slump. This kind of tree indication is soil creep, and a big massive chunk of earth flowing down in a big mass motion at one time, that would be your landslide or mud flow. And there are some beautiful trees that, I mean, people can sit in these, you take pictures in them, but that is a soil creep indicator. We know that this hill is actually slowly creeping down the hill. Gravity's winning. This is a railway footage of, you're going to tell me what it is in just a second, and you're going to look at the, is that creep? Is that a slump? Or is that a landslide? It pushed the entire railroad tracks out of the way, by the way. That was a bigger one, but what was it? This actually flies you through, and you can see some more. If you want to go back and look at that, go ahead and look in the notes. You can see the railroad tracks, if you watch it a couple times, have really been pushed over by the land. It moved railroad tracks out of the way. All right, what would this be? Is this creep or slump, or is this a landslide that can drop a huge rock from high up, in this case crushing a car? Again, that's why they have the signs on the side, beware of it. What's this? Landslides, soil slump, or soil creep? You need to tell me that, and I'm probably stopping the video and asking you that. And the last one to identify, which is this? Landslides, soil slump, or creep, soil creep. So really, if you look at mass movement, we're looking at erosions processes that has now moved our soils. And there's three ways: big massive amount at one time, landslide; slumping down as we lose the foundation underneath it, and moving, you could see it go, but that's your soil slump. But a very slow gradual creep down a hill, that's your soil creep. If you have questions, as always, jump on Zoom. I'm happy to go through this if any of this didn't make sense, or email me. Have a great day.